Elon Musk recently compared the Model 3 to the difference between a car and a horse at the point of transition. And I want to outline a couple of areas where Elon may not have gone far enough to expand upon just how big this shift to autonomous electric is. The first thing is a decrease in transport costs. When we're at a point where, at a system-wide level, autonomous electric cars are 3 times safer than humans, then all of the accident costs around that go down, which means repairs, insurance costs, manufacturing costs, but most importantly, in a place like America with such exorbitant health costs plummet. But it's not just the cost of medical care and hospitals. It's the cost to life of being off work, of being afraid, of having chaos and disruption. Labor costs go down with autonomy, and they really go down when you bring in the concept of autonomous trailers or autonomous pods. And I want to emphasize this for a while because it's such a big deal. As soon as you've got autonomous storage, autonomous pods, autonomous trailers, a number of things can shift. First of all, it's been commented that the cost of tires is exorbitant. Well, one of the things that having people inside vehicles leads to is the whole transference of image and identification. So if it's my vehicle, it has to be cool, which means it has to be expensive and comfortable. Now, when you link a small storage pod with a pickup, for example, and why do we do this? For, like I've owned a pickup for 15 years, and I'm a contractor, and the bed of the pickup gets used a couple of hours a week. That's it. So why do I drive the bed of the pickup around 100% of the time? Because I can't summon the pickup bed, and I just might need it, and I don't want 2 separate vehicles, and I don't want to have to anticipate every time I leave in the morning, might a client call that needs this, might the crew need, an extra little bit of lumber, this and that and the other. And so it's there 95% of the time doing nothing. But because it's there and because it's attached to my vehicle, it has the same human comforts for suspension. It has the same nice paint job. It has to match. It has to be made by Toyota. So there's all of these different ripple effects because it's constantly linked. Now, why not just have a very tiny thing and a trailer? Well, first of all, we haven't had that paradigm. But then you get into trailer dynamics like, I don't want to haul around a trailer, clunking and noisy, etc., behind me and parking, etc. It's a nightmare. And so we also then have this problem with, the cars not being built to haul trailers, the weight, and the feeling of, impact and speed. Now, all of this shifts with autonomous electric trailers. And I want to talk about 2 partitions in that shift, because if you have 2 independent motors for the rear wheel axles, if you have 2 independent motors, that pivots the trailer. You can go backwards, forwards, in sync slightly, and you can steer and pivot the trailer, 1. 2, If you have sensors on the trailer, you can, stop the trailer, etc. You can have full autonomy on the trailer. 3, if the battery pack at the bottom of the trailer, it can go forward and back, as many trailers already do this for weight distribution on large heavy equipment, and they'll use hydraulics to send things back and forth. But basically, if a very small motor assesses the weight point at both points in the trailer, has a safety algorithm and can move the battery back and forth in relationship to the rear wheel axis, then regardless of what's going on in terms of different load and weight distributions in the trailer, regardless of speed, etc., the trailer can be perfectly weighted. Now, similarly, most trailers today don't have a battery pack in the bottom, and this makes them much more bouncy and probable to blow over. You've got 2 points, you've got this narrow beam connection. So once you have the hardware capabilities, basically 2 small electric motors for a trailer, and we're not looking at performance here. And this is a really big distinction when you partition the utility function, the transportation function for lumber, cement bags, sand, emptying a septic tank, road cleaning. When you partition this from the things that a human would want to be in to drive, you create a whole different protocol for safety. For example, rather than spending $10,000 to make the crash impact on this trailer perfect so that it wouldn't hit a human in the middle of the trailer, you actually make the trailer expendable. This is the area that humans don't go, and therefore you want to protect the human who's banging into it, people who are still driving their cars. And in doing so, you increase human life safety by making your things more expendable, but that also decreases manufacturing costs while generating a driver cushion. Having a battery that goes back and forth does another thing with range, because currently, if you add a trailer, you dramatically decrease range on your car. But if it has its own battery and its own propulsion, it could even conceivably do the opposite. If you added an extra battery pack, it could even feed and extend the range of your car. A trailer that doesn't need windows because it's autonomous and who needs windows in a trailer, can be a bigger solar bank than any car. Again, getting rid of the coolness factor, but you've got a flat panel roofs that make it ideal places for self-charging. Meaning you can have it drive itself to a sunny point, sit there all day, and then reconnect and be used as needed, or of course connect into an electrical network. The distinction I want to make is between fully self-autonomous trailers and cars that are towing it. And I would say cars, why have a truck? So this gets rid of the whole needing to beef up a truck engine, or a car engine for that matter, because sometimes it holds a trailer. The trailer always holds a trailer, and so it has an engine to manage the trailer. And certainly, if you were to put 10 tons in this trailer, and that's a bit hard on this trailer motor, the fact that the car has its own motors, particularly the powerful motors of an X and S, a Model 3, or a pickup, means that these two vehicles can be synchronized to share the load intelligently. So you can link the speed, the brakes, etc. You can create a pairing dynamic. So once you have the motor and the sensors, the software is already written, so it's available. Tesla has billions of dollars worth of valuable software already in the car. Now, as soon as you create an Ethernet port or any little connection, the trailer is now as smart as the car. So you've got an instant doubling of value. But you also have a 1/10 the cost for that instant doubling. So it's a huge return on investment, and no cost, other than a little bit of internet bandwidth. So zero, there's no downside. It makes the front vehicle more valuable, significantly more valuable. If you can have a sedan be bigger than a pickup or not carry the storage, that's more valuable than a pickup in several ways. Parking, for one, because most of the time you're not going to be lunking, this trailer around. So parking is easier than a pickup. But you've also got, when you add this component, you have 300 to 400% more space than a pickup because of the higher walls, the dedicated area, etc. So you've got, and then to manufacture a fiberglass or aluminum body, done. The drivetrain, of course, is important, and this leaves lots of room for customization, which is important. But the distinction I want to go back to is between unplugging the computer in your car and sticking it on the trailer, because you've got to have a connection port between its sensors, etc., and the prevailing, the whole system, the internet system, all of that. You've got to have a port. And you have the choice to either just plug that port into the vehicle that's hauling the pod. And when I say hauling, I should say guiding, as in a convoy. Because all that has to happen in order for you to haul is, rather than the typical ball, thing that's ugly, and I've got a ball on the back of my pickup, it bangs into things, scrapes roads. If I back up as I'm parking, the ball sticks out 6 inches beyond, and it's hard, so it could scrape someone's bumper. So rather than having that technology, behind the ball is a 2-inch hole where the ball point slides into. That hole is available for a trailer to insert its own 2-inch bar on its own intelligent axis, so that it can basically be completely self-driving, or extend this little tongue here into that hole and grasp, and then extend into the electrical and data connection inside that metal tongue. See now, and then the pivot, the swivel point is back there that allows the trailer to find the socket and then retract it for self-parking, for example. You may get to a point where there isn't quite enough parking for your car and your trailer, and you can tell leave the pod, and then go park the car somewhere else. And there can be different size pods, including pods that can go into parking places this way as opposed to this way, because they're tiny. Now, we get into this convoy concept for example, moving house, or going on a road trip, or living in a lifestyle change where you're doing artisanal work and traveling around the country, living in this pod, bathing and socializing, storing supplies in this pod, etc. And so you can have a convoy concept where at the back of this trailer is a socket. And the pod behind it can link to this socket. Again, its battery weight, distributes to the right point, and it's all being navigated and run by a single computer that's in the car. That's the $3,000-$4,000 unit. And I make this distinction because the $3,000-$4,000 unit can come in the trailer. Now this will be over time, but I just want to delineate that there are choice points. Once you have the socket for the input, the algorithm that's going to be guiding the car, and you have the monitor receiving the internet connection, etc., and you don't even need a monitor, frankly, and that would lower cost because you don't need to touch inside a trailer. So it'd probably be worth having either a redundancy so that the car computer could actually brake, and the computer at any one of the convoys, they'd all have to brake before the whole convoy would lose intelligence. And they could be multiple sources of redundancy. But in the in the trailer, there is simply a socket where you plug in the chip, the computer, and you don't need the monitor, and you use your app, etc., to program it on a phone. Or you could take the car computer out and plug it in. It can come with the data with the ability just to be towed by a car, or you could add the chip, the computer at any point. And back here is your point to endlessly extend the convoy. In practical purposes, you probably would never, you and I would never need more than 3 pods moving along. But imagine the type of transformation that this facilitates. So we have things like, for example, you can have airless tires. That's one of the Tesla gripe points because the weight you run through a lot of tires, and it has to look really cool and all that. But if you just understand that, you're going to start off with a large tire and then gradually, if it's a high weight, high torque type thing and, braking and all that, it's slowly going to go down. That's fine. There's no problem with that. It doesn't have to look cool. There's no, so you've now eliminated flat tires, reduced cost, extended, lowered maintenance and extended duration. So we have, of course, reliability because we've eliminated the drive. Now, this may not sound like a big deal, but I'm a contractor, and I can't get my crew all the time to charge their phone, carry their phone. So I sometimes have to drive somewhere just to see, why aren't you answering your phone? What's going on? And are you, where are you? Where are you? I don't get instant GPS updates to say, okay, the crew said they were going to be here in 5 minutes, and they are 5 minutes away. And I'm seeing them on my phone and my alert, or I'm getting an alert that diverges that they're not actually going to arrive when they said they will, and that kind of thing. I don't get that with people. With something like this, I can make an appointment on a GPS grid and say this thing with whatever has been put in it, will and should arrive at X point. Now this leads to a much bigger transformation in lifestyle when we look at My Garage. My Garage is an eclectic mix of 10 years of worth of sometimes needed tools and materials. Meaning at the end of a job, I decide whether to throw away a perfectly good material or give it away or find some little nook in my storage system because it's worth $100, but I'll need it sometime in the next 5 years. Sometime in the next 5 years. And that is what my garage looks like. And currently, my garage could not be robotically managed. Because, you can't ask a robot to go up here, down there, move this block aside, put that, okay, where's that bolt, back up and stuff. And so I throw away stuff that I will need, but not in a timely, reliable manner. I don't know where else to put it. I have 10-year-old pieces of stuff that I might have used 5 years ago. It just didn't come up. Or maybe it did and I bought it again because it was tucked behind something. And I forgot that I had it until after I bought it again for another job. Or I got to the job and it's like, oh, I forgot that thing. So let me just go to a local hardware store and buy it rather than drive back to the house and back to the job and stop things. And so these are human issues. And I can't even delegate to a crew member how to find stuff in my garage. I mean, for big stuff, there, go get the rototiller, go get this. But then do I want them having the code to my, $20,000 of tools? What if they leave the door open? I can't tell. There's so many risks, uncertainties, little nuances that the human mind is necessary for. And when I got this house, I chose it for its storage. As a contractor, I'm thinking, does this have enough place for me to store junk, tools, useful things, whatever, stuff that I don't need all that often, but when I do, I need it now. So this is the kind of thing that this takes out of the picture. Why? Because once we have autonomous pods, you now eliminate one of the big reasons I don't go off and have a separate off-site storage. I don't want to have to go and drive to a storage place, particularly load up my truck that day for what I need that day, then drive to the job, then drive back, unload so that it's not laying in the back of the pickup and doesn't get stolen, put it back in the storage, and then drive home. So I carry around a lot of things in the truck in toolboxes that I don't need 90% of the time. I just bought a pair of pruning loppers that I hadn't noticed because I hadn't used them in a year. No, I hadn't used them in 3 years. I don't do maintenance, but I need them every now and again to, install and stuff. I hadn't used them in 3 years. So I'd forgotten that they were in the truck being driven around for 3 years. So I bought them again. I went to put them in the truck and realized they were still there. So I hung them up in the garage where they will not be used for 3 years. That's $40 and 5 pounds of weight being navigated all around, polluting the environment because I might need them driving up to a site and then there's a branch in the way or something and I wasn't prepared. And so there's this incredible inefficiency. Now imagine a quality control robotic inspected tool rental place that I could pay into, where I would give all of my junk, all of my tools, all leftover materials into the pod, where the robots in a centralized warehouse. See, we're learning from Amazon here. Amazon, of course, their delivery costs would plummet around this. But we're learning from Amazon here because now they take things and you can categorize it and store it for you. You can keep your junk in a centralized warehouse organized with Amazon technology where you take a photo of that, you cross-reference it. It's, self-suggests you put it back in the crate that's always labeled this so you don't have to type it in every time. this goes in this crate, this goes in this crate, this goes in this crate, so that you can order up your list of tools and materials for today, or you can group it by batch. I am going to be building a fence. You just type fence. And the pod goes to all the leftover lug nuts, all the leftover bits of concrete, from the last job, all the, everything around fence gets brought to the job. And you just order additional materials, sending this to, a lumber yard to pick up the additional materials. It's there on time. And you just tap that and it's there when you need it. But it's not in residential areas. Now, here we get into synergies with tunneling. Because if you can correlate this pod in some way with robotic tunneling, when I say robotic tunneling, I just mean the summoning of specific pods at specific times. Now you also can do that, in any neighborhood. Every neighborhood can have its own tunnel system underground. You just look at any slope and tunnel into it and do a loop, or you go straight down, tunnel down, 300 meters, whatever it is, and figure out how much water needs to, how much space at the bottom needs to be there for settling water and stuff like that. And you just have an elevator system that can organize the pods and pop one up into the self-driving chassis, where you have the pod comes up, sits, mounts onto the chassis. So now you've got your own self-storage at, again, significantly below cost in all metrics. You've got utilization of, you're simultaneously creating cultural reservoirs of diverse environments. Let's say there's a hurricane. Well, you could decide to empty the storage pods, people being more important than storage pods, and everyone goes into the tunnel. And when it's all electric, etc., there's ventilation, etc., it's guaranteed safety. And these pods can group and balance and weight themselves. If the wind comes from the one side, the battery goes forward and they, huddle, there in the area, and there can be a storm protocol, and people are in the tunnels. So you when you create diverse environments, you create a resource for the community that isn't there otherwise. So when you can create a diverse environment that is more cost-effective by a large order, and cost-effective in multiple terms, because I drive by mini storage, that's demanding attention. That's blocking the view of the bay. That's decreasing the quality of my drive. And if I go in there, the whole thing is a nightmare. Show my key, is it the right hours to visit my own things, go in there, prove ID, this, that, the other, all to get into some bit of stuff that isn't all that important. And then it's like, well, is it worth the effort and the high rental costs that, trends turn money away from much more important things for our species, for our planet. So when you have tunneling and storage, you, with self-driving, you have a synergy. You have a synergy that does a number of things, because the next level in this is quality control, maintenance, and checking, such that you have either people or robots in the rental fleet who check the reliability of everything that comes in, so you don't actually have to own things. We're moving into the sharing economy, where you dial up a sledgehammer, a perfect, excavator or whatever, and it arrives reliably in a self-driving vehicle such that you can give up ownership, so that all those things that I've been storing for 10 years, they can be used immediately. This cuts down, see, because when you have this same pattern replicated thousands of times, meaning there are thousands of contractors doing this exact same thing, some with bigger piles, some with less piles, which means there are literally millions of tons, as this all aggregates up, that are being thrown away because of inefficient ways to store, share, recycle, or give. See, I sometimes put stuff outside, hoping someone will take it, but nobody knows it's there. And so it takes a week, and then, like right now, there's rain happening on a speaker that I stuck outside for free. It's a great brand new speaker. I didn't need it. I didn't want to drive to the Goodwill. I didn't want to put it in the garage. Here, someone have it. Sometimes it goes like that. Sometimes it disappeared. But this is the kind of waste that is going on constantly. And maybe the person who takes it took it because it was free, not because they really needed a speaker at that time. So then they store it in their garage for months at a time. So in other words, we get rid of garages is what is the bottom line. We get rid of garages and we increase the efficiency of storage and transportation by 95%. In part by seeing that, for example, I have a drill downstairs in the laundry room, so I don't have to go upstairs and get the drill that's upstairs in the kitchen. So I don't have to go out to the garage to get the 3 drills that are in the garage. And these drills get used less than 1 minute a week. That's 1,000, there's 1,000 times potential to increase that efficiency. But at what cost? You see, this is the potential, that autonomy, because we're of course moving into the direction of robotics and assistance, where there would be one drill in the garage, and I would order drill, and the assistant would navigate the grid. It's of course way cheaper to train an assistant to pause if they don't know what's going on and navigate an existing grid. Your job is just to deliver stuff to and from the garage or to and from the pod that drives up. Because now you have communication here. You also, of course, have labor things. Like the biggest labor cost in my landscape project this week has been driving to the stone yard, because there's a tricky job site that the large trucks at the stone yard can't deliver to. Okay. We go back and forth with pickups, getting heavy loads of stone with often 2 people in the truck, drive to the job site, park in a difficult way, and then lug bits of stone up 200 feet of steep slope, up one big rock at a time, to build a stone wall. 90% of the cost of the wall is transportation of little round things up to this steep hill. This is also something you can order an integrated delivery assistant at some point, where you map out the terrain, you teach them, because that's how I teach my crew. I get to the job site and I say, look, we're going to take this, follow me, we're going to walk up here, and we're going to put it here. I want a big pile of this. Okay, have at it. A day later, 5 guys lugging stuff up, and there's the pile. Of course, they're tired, and it was not particularly creative work. When those types of things, I need a trench. See this line here? I've painted a blue line. You understand this? Okay, good. I need a trench, 12 inches deep. I don't need it wide at all. I just need it an inch wide, but our picks are 4 inches wide. So if you could just use a pick, that's the best tool we have. So run along. A day later, all those trenches are open. What next? Okay, well now, see, I needed very little. These are things that can be delegatable. But again, is a robot too expensive to be kept? What about the fact that I take 6 months of the year of vacation, travel abroad? Well, what happens to my $100,000 robot? That sure, it only costs me $1 an hour rather than $25 an hour, but $100,000 in capital. You see, you can now link assistance and delivery assistance in different ways with the self-driving vehicle as part of the network. Now, obviously electricity has many, many, many benefits. I don't have to listen to the noise. I'm moving to all electric power tools so that I don't disrupt the neighborhood, because I don't enjoy listening to my neighbor's gas mower. I don't enjoy listening to the gas blowers. So to be respectful, electric lawn mowers, electric chainsaws, electric leaf blowers, etc. I don't want to smell it. I don't want to listen to it. Of course, you still have the dust, etc. with blowers, but so we have electricity is cheaper, of course, better air quality for everyone, better noise environment. So this is a huge benefit. There are delay costs in jobs. If I get a delivery right now from the stone yard, they say we'll be there between 10 a.m. and 2 p.m. or 2 p.m. and 4 p.m. So it's like, okay, I have nothing to do until you arrive. Do I just waste 2 hours of my time? This is the kind of thing that you can organize when you have an app alert you, your supply is on the way. It will arrive in 29 minutes. And you say, go. And your car links with that and meets it there at 29 minutes, and no time wasted, no irritation. Now, so I think you grasp the easy option even without sharing things. There is an easy way to reduce transportation costs in delay, costs in money, costs in reliability, costs in hassle, all of that by 95%. There's also then the ability to utilize things by 95%. In other words, to make the vast, we are the most energy intensive culture in human history, meaning the amount of money and natural resources, and they of course tie together. So let's just say natural resources: electricity, gas, trees, more gas moving everything around. The amount of energy that I use, or the 102 tons of garbage that, because we get into now, self-driving garbage pickups, which leads to facilitating greater complexity in recycling, because again, you're taking the labor cost out of that. But the amount, so as an American, I'm going to generate 100 tons of garbage, 100 tons out of 200 pounds. That's the current system. And we've already covered the fact that, probably 95% of my things are not used 95% of the time. Even this turtleneck that's going to get used for 6 hours. Well, what about the whole closet sitting there filled with turtlenecks just so I can have a little color variety? Again, clothing, kitchen, bathroom, tools, car, different rooms, 95% vacant. What about the hot tub that I haven't gotten into for 2 months? 95% vacant. The ping pong table that I play all of 2 hours a month, 99% vacant. So we have basically, in a time of ecological crisis, a system that ensures, if we want to let's just say 95% waste all across the board. All across the board, 95% waste. And so electricity and autonomy, sharing, tunneling. The real resource here is, of course, creativity and innovation, has the prospect within the next 5 years on a technical level of eliminating all of that. Frankly, if we had that unified together, if we had, Jeff Bezos, Elon Musk, and 100 competent experts around them that are not currently being employed. Some of them are, working in this or that. If we had 100 competent experts and each one tackled a bit of this with no interest other than to solve this energy loss. In other words, we have one goal and one goal only, and that is to eliminate 95% of waste in cost, in things, in environment, and to synergize. And that's the goal. See, the goal is not to maximize shareholder value in this kind of thing, because then you immediately fracture. Well, we want a proprietary. We don't want to make our trailer the same tow hitch as everyone else's trailer. We want them to have to buy our trailer for $10 more. So for $10, the whole system fractures? Yeah, because our shareholders want that value. Otherwise, they're going to go and invest in that other thing. So we, it's technically very visceral and very there. The question is the mindset. And of course, we have 95% waste in the mindset that we use. The software that we use to navigate wastes 99% of our energy over other, more intelligent forms of partnering as human beings that could create more well-being, more safety, more health for all concerned. And that's a much more difficult thing to track. But one of the ways we update our mindset is by externalizing outer technology. We build a computer and then we start saying, well, why isn't my brain as smart as a computer? And then we start challenging our thoughts to change, which is the real, innovation in technology. So we have enabling mobility. Now, one of the things that this moves towards is, we have a left brain, right brain, and this is not even accurate. This just shows us how out of date we are just about any time. By the time, we catch on to the paradigm, we used to think it was left brain and right brain. It's actually something different, but we all understand something that's not accurate, which is that we have the artistic brain, the right brain, the left brain, and that more the mathematical and strategic brain. So what we currently do is we emphasize people with the mathematical and strategic brain because right brain people don't get much done. Artists have grand visions, and then they get waylaid by a vision on the way to buy the materials, and they don't have organizing abilities, and they're saying, oh, what about this and what about that, and the crew's just saying, what do I do with this hammer, and so we currently, as a culture, prioritize technical implementation over vision. And you can see this with Elon Musk right now, because his vision exceeds the vision processing capacitors in the people needing to measure his value. You have something like Autonomous Day not affect the shares, but something like a tweet or having a puff of marijuana affect the shares. Now, what this means, and it's terrifying, is it means we are completely insane in our decision-making algorithms. It's terrifying to realize just how crazy we are as a cult, as a culture. Now, this is also an area of hopefulness, because AI would not tolerate that level of stupidity. Now, AI is very interested in the underlying physics and maths, etc., if you train an AI that way. And the share price would shoot up if AI was voting. But with human beings voting, not so reliably. Who knows? It's a crapshoot. And that's a big problem of its own. But the shift towards art comes. The shift towards art comes when I can wake up in the morning and have a vision and draw it out on my tablet. And I don't need to start a company and train a crew for 10 years to be able to implement my vision. I just need to send the concept and the image of the vision to 20 other people that are interested in beauty or this, that, and the other. And one of them needs to say, I want it. And then that's when the different autonomous unit, one starts bringing the glass for the project, one starts bringing the heat torches for the project, the paints, etc., and they start coalescing, and I get to do the 10% of the work that is art, which elevates the value of the art by reducing the cost of the art, by reducing the bureaucracy and transportation of the art. So art actually moves up in value as a result of this movement towards energy efficiency. Because that's also the one thing a robot cannot do. A robot cannot make more beautiful, heart-touching poetry than I can. They can't make a card out of an inspiration and talk about how it relates to a dream. They can spray a replica of the painting much faster than I can and more efficiently, but they can't make the emotional connection. And as Tony Robbins says, ultimately everything is emotional. We all want to feel good. We don't want to feel bad. It's pretty much that simple. Well, we don't feel particularly touched emotionally because a robot made us a cup of tea. In fact, one of the problems with automatic ATMs and all that is that people have become less grateful, which damages health, which reduces happiness metrics, because they're not grateful to a machine for printing a receipt. But if they saw a human writing that out, they would say, thank you for writing that receipt. And they'd mean it because they know what it's like to hold a pen for 2 minutes and write a receipt. When they just press enter, they say, why doesn't this fucking ATM have a faster computer? This piece of shit, it's raining out here. And they have zero gratitude for the technicians who built the computer. So we're eliminating gratitude to the degree that we're interfacing with machines. So it's not that this is a panacea of happiness. And that's one of our cultural blind spots right now, the idea that because we're a materialistic cult more than any cult in human history, that if we just get the material right, suddenly we'll be happy. We may find ourselves enraged at our assistants that are twice as fast at bringing something from the garage as a human being, but that we feel no gratitude for. And even though they're twice as fast, we're irritated that it's not instant because we have hedonic adaptation addictions to dopamine, so we want it faster, more intense constantly, to our own detriment. Now, we also have the possibility of ending homelessness with these types of things. Because, for example, right now you need your own sewer tank. You need your own water reservoir. You need your own water hookup. You need your own power supply. You need a whole grid of stationary, massive objects in order to fit within the current paradigm of design. But what if you had a 30 or 40 gallon, let's then transition from this delivery trailer into the same chassis and navigation and all that, but now we're creating modular homes. A modular home that you can just get in your car and drive, and the module can follow you later at a slower speed and arrive afterwards, so you can cruise along and park and do this, and the modular, you stop off on the way and eat lunch, and the module continues on at a slower speed in a lane in the highway designated as 2 speeds for modular delivery. Why not? Why not let them use the curb, for example, except when emergency vehicles need to come in or whatever it is. So you have, or tunnels, let's send it by tunnel. We enjoy the surface route. So you have many, 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 many options. And a standardized system where there are standardized size for tunnels, where some tunnels are vertical, some tunnels are this, some tunnels are that. You've got, earthquake safety, the whole variety of, different things. and you can use this. It pays. It pays to have certain standardized sizes of units. One, two, certain standards for chassis, certain standards for hitching. I mean, it's really good that there are not 300 varieties of AA batteries. There's 300 companies that manufacture AA batteries. But you can put an AA battery from any of those companies around the world into a remote, and it works. That's really, really, really good over proprietary battery, bullshit. And so in this type of situation where you have self-connecting convoys that can deliver themselves to an underground electric rail or an underground tunnel that they can drive themselves through with their own electric motors, to have your stuff arrive before you do and even have people unpacking it. Having sentry mode, security awareness that people are not stealing your stuff, knowing where it is, GPS locate, being able to look at camera and see what's going on, around in the location, being able to facilitate from your location, for example, deliver stuff to a client. I'm sending over some tools and materials. Can you take delivery? Okay, here it is. And you can video conference, etc., through a monitor on the trailer, etc., with people by, through the cameras system and a speaker. Be able to say, oh, I see this, that, and the other. This is my decision, and you can interact with passers-by and see what's going on. And this may be important because people get very angry at machines if they're doing something rude and no person is there. They vandalize that or something. But if you can have someone knock on it and say something, and that comes back and you can respond, it creates freedom in location. But in the terms of ending homelessness, if you have a water pod, this is what they do in Thailand. They have water trucks, and they have lots of restaurants in beautiful locations that don't have wells or that don't have a municipal water supply. So what they do is they drive big, smelly, diesel trucks around with 1,000 to 3,000 gallon tanks in the truck, and they just pump water into the reservoir of 1,000 gallon tanks at the restaurant. But this takes it to a whole new level. We can have 30-gallon tanks where the pod comes up, feeds in automatically water from its 1,000-gallon tank into your 30-gallon tank, tops up 20 living units, and you've now got shower and drinking water. You can have battery swaps where you're delivered a new battery because you're using high wattage for some reason faster than your trailer can charge. So you can be delivered bricks of power where you just come up 3 bricks today, leave it on there, or pull it out. The thing has the code, pulls it out robotically, puts in new power, off it goes. So you vacuums out the septic system. You have a little tank for your sewer. You don't have to have your whole personal drain field. That unit then takes it to a centralized sanitizing and manufacturer of fertilizer. So it eliminates all of the germs, packs some things into dry bricks and ships them off to the local farm, packs other things into a liquid fertilizer to fertilize the local sports field. And this is delivered autonomously with a much better network and a much lower cost point. But what we're doing here is we're turning this into a $20,000 living unit, and as low as a $5,000 living unit that has mobility, where you could even travel in the convoy in your home, not even need a car. You just join up if you need to move, or you come into situations where it's set up to form roving communities in this type of situation. And when you increase the level of strangers and unknown, you decrease the level of trust. So then you've got to build that in with app technology where, people that build profiles to understand that as you connect with someone in this pod, your well-being goes up. And so that's a valuable connection and a new form of intelligent competition. Ultimately, what you have is a new paradigm of design. Every new technology creates a new lens. How do we reinvent the world through this lens? There's this lens, there's this lens. How do we reinvent the world to fit through this lens? Well, when you reduce the cost of energy by 95%, and of course we're doing that simultaneously as we're moving to electric, we're reducing the cost of electricity day by day by day. We have so much abundance. We have so much waste. We don't know what to do with all the natural resources we've got once we enter the paradigms that free up 95% of this waste. Briefly, I wanted to follow up on a couple of design details. One is the retracting and extending tongue that comes out to whatever length and makes the connection with the tow package in the vehicle in front. And it's important that it retracts so that this can park and also to allow for its own autonomous mode. The second is to acknowledge this self-retracting tricycle wheel. The tricycle design being less stable than a four-wheel design is nonetheless appropriate given the fact that with a battery pack you have a very low center of gravity. And this allows this to be used as both an autonomous pod and in convoy and as a trailer. In autonomous mode, this wheel basically drops down and is the steering wheel for the vehicle after a fashion because the propulsion is really steered by this, and this is simply adjusting to facilitate the steering. And this allows for self-parking of the trailer. It also allows for one of its most important features, which is self-connecting and self-disconnecting from the vehicle. In other words, when we have a vehicle in front with a hidden receptacle, this pod can drive up into position to where it's within 6 inches or so of this tow package. It can extend itself up and down and lock in place and synchronize with the computer such that when the car takes away, these self-propelling wheels make it an effortless experience, and the battery pack that's in the car here or in the trailer here is providing all or most of the power. You then have the same point here where other vehicles can self-connect to form a convoy. So these are a few things on the underside of the battery. Now the battery can have a couple of different options. One is, and this is, just options. I'm not clear how important this is, but the battery pack can either cover the entire underside of the trailer and be accessible through the floorboards and or the underside, by floor panels, or it can be a portion. Now, if it's a portion, then you have the opportunity to distribute the weight easily just by opening up the floor panels and deciding where to slide the battery pack, as it connects. Another nice little design feature, these little bumper rubber points. You see them on the post office where you make frequent stops. It just increases the safety of the vehicle, rounded corners, aerodynamics and safety. But also, if it's fiberglass or aluminum, it's an incredibly comfortable crash zone to crash into this vehicle. My sense is that 8 to 12 feet long is a good distance for a pod, but you could go up to 20 feet and consider them, you want to think about parking spaces, because imagine if you drive in as a convoy, you have your Model 3, you have 3 pods being in convoy behind you because you're a moving house, or you're now a roving band. You've got your band equipment in one pod, you've got your sleeping quarters in another pod, you've got some friends, in another pod. Obviously, the people pod needing to be more of a minivan and much higher safety standards. But keep in mind that with the electronics, safety standards is death per million rides. It's not a certain number of crash densities, or certain type of aluminum or something. It's deaths per million rides. That is a software issue. It's an intelligence issue. It's a speed issue. So you have many, many ways to continually improve. You want to be on a continual safety improvement with each iteration, where less people die per million rides or per million hours in the vehicle. And that's all that really matters. This gives a lot of innovation to decide whether the best way to save human lives is to put in airbags, for example, or to spend $1 billion on software innovation. Because who wants airbags exploding in your face if you can actually decrease the amount of collision and accidents to begin with? For that matter, you could have outer airbags where reckless human drivers, driving into your vehicle, would have the panels of your vehicle explode towards them so that they hit your panels inside an airbag and cushion your vehicle from their recklessness. Now, one of the more interesting things that emerges as a natural outgrowth of this autonomous pod technology is tunnel convoys. Now, this is valuable for a couple of reasons. One, it allows slow and fast speeds in a convoy setting. Secondly, not many people enjoy riding in tunnels, and so this frees up cargo transportation, but it is certainly available. And basically how this would work is a pod drives itself to, and I'm referencing the concept, that Elon was talking about with his tunnels and elevators and all of that. But in a convoy, the self-driving transport pod would drive itself to an elevator, and a crane function, or it could be built into the walls, either way. But basically, the vehicle is dropped down, and the convoy anticipates it. This is where the autonomy network is really important. Having all of these grids be autonomously controlled means basically that these speed up. This slows down slightly, just enough to insert the pod. Then the tongue goes into the convoy again, and it's all navigating in sync. Now you don't have things bumping into each other. Or maybe it's just a 1 foot spacing. But you have the option with this tongue. And it proceeds, and you have one tunnel heading south, one heading north, touching off. And every town has its pod, so, or every neighborhood has its elevator, so that, Amazon and other deliveries are coming through this network of tunnels and then being lifted up in the right neighborhood. They position themselves into being and leave their package. This would need a little autonomous delivery robot in order to exit the vehicle with the package navigate to the desired GPS location. Every homeowner would specify where the package is to be left by GPS location, and the package would be dropped, a photo would be taken, a text or image sent within seconds automatically by the robot. This is the package at this location, at this GPS coordinates, and is then on its way again. We see massive savings as a result of this. I'm Dane Rose with Happiness Data, happinessdata.org, and thank you for watching.